So let's start with my topic. I would like to talk today about relationship between prehistoric demography and social transformations and woodland. So prehistoric demography, I'm sure you're all familiar with that. What is that, or what are the questions in that direction of archaeology? So archaeologists who are studying that are very much interested in how many people lived at a certain moment, at a certain place or area. And so we are trying to think about population density, or how many people lived in one household, in one village or settlement. We are thinking about population structure and all this related to that. However, that is very complicated to reconstruct because we are not excavating the inhabitants of some houses. We just have the house. And of course, the size of a specific household can be different in a Neolithic or Bronze Age and Iron Age. And therefore, we have in demographic archaeology only some relative measures of population estimations, or sometimes we have also absolute estimations. So these estimates are usually based on C14 dates, or number of sites, or size of the houses, or there can be also inferred from burial grounds, etc. And all these parameters, all these measures we are discussing within demographic archaeology are also related to social factors. So there is a huge amount of literature which is discussing, for example, scalar stress within the societies, which can lead to violence within the societies, between the communities. We can in archaeology also discuss the level of cooperation or competition with larger societies or smaller societies. We are definitely discussing, especially in the last 10, 20 years, the migration between different regions, between different communication. We are discussing very highly human mobility nowadays. And also what else we are discussing in demographic archaeology, because we see some increases and decreases in the amount of people living somewhere, how they adapt with their technologies to different environmental conditions, for example, to climatic changes, etc. But where is the woodland? Why I want to talk about woodland? Sometimes we are a bit forgetting woodland, but woodland, at least in temperate Europe, was the most significant component of the environment. That was really like the most significant one, and not only by the scale, which was woodland covering the whole landscape, but also how important it was to the prehistoric communities. So they obviously built houses from that. They used different tree parts for different products of them. They used fire not only for their pyrotechnologies, to fire the pottery, to create metal artifacts, but also they used fire in extensive land use. They also applied different woodland management in different areas. For example, here in Britain, you still have specific woodlands which are managed in a traditional way, for which we have evidence of continuity from the Neolithic or even from the Mesolithic. So woodland was really very significant part of the prehistoric environment. And I usually use this example to illustrate that. So this is the Iceman, and if you have a look on the artifacts of this specific individual from Copper Age. You can see how many tree taxa he used or other people used to create material culture found with him. So we have several, and these are just trees. There are also many other plant materials used for the artifacts found with him. The most significant artifact used for the interaction with woodland was obviously an axe. And I would say that axe is also one of the most commonly found artifact, especially for the Neolithic period in prehistoric Europe, I would say. It is not only within the stratified sites, but axes are also often found as single finds as a surface finds in the fields, etc., etc. So, and I would argue that this was really the key artifact of the prehistory, because the people needed access actually to manage the landscape, to do all the woodland management, and not only the deforestation. When some people or some archaeologists, sometimes we just forget that deforestation is not the only possibility how you can interact with forest, but you need to manage the forest to get the products and raw materials you need. And I would argue also that that's why the axes are also in prehistory also so important socially. And that's why we found them in hoards, we find them in graves, etc., etc. So archaeology has quite a lot, I would say, to say about woodland. There is quite a lot. The other discipline dealing with woodland is obviously palaeoecology. So palaeoecologists are usually going to some wetlands. They're sampling the sediments there, and from pollen they are creating these pollen diagrams, reconstructing the vegetation in the surroundings. Palaeoecology nowadays is going in this direction. So a lot of paleoecologists who are familiar with modeling procedures and quantitative methods are nowadays using or creating woodland models which are covering large areas. So we can discuss the woodland development on the scale of continent. And this is not obviously happening just in Europe, but also on the other continents of the world. The question is where these disciplines can meet actually, and maybe we can have a look on very basic definitions of these disciplines, and you can see that there's a lot in common. That archaeology is studying past societies and their environment, and paleoecology is studying relationships between organisms and their environment. So we can say that this is very, very similar, and that is a common ground for those two disciplines. The other common ground for paleoecology and archaeology is the shared temporal window, because we are both looking in the past, and we usually can say something about the organisms and their environment on the scale of thousands or hundreds of years. If we try, we can also find the shared spatial scale, and then we can create some interdisciplinary research. However, we are still a bit struggling. So different research communities in different countries are still suffering of this because of this I would say, artificial distinction between nature and culture, and therefore archaeologists and paleoecologists, when they study, they do not talk to each other very often. So we are not trained in our professional practice to understand our research questions and understand the theories behind our own research. And the other problem is coming from archaeology, because I've shown you the big paleoecological model of some woodland on the continental scale. The problem is with archaeology. I've shown you also one very individual case of the Iceman, telling you something about the woodland raw materials this person or the society where he comes from used for his artifacts, but can this be translated into a continental model of woodland? Probably not. So the problem is that archaeologists often work as a site. Their work is usually site-based. So we are interested in a specific site which has specific dating to Neolithic, and then we are missing the long-term perspective as the paleoecologists can have. And the other problem is that paleoecologists often do forget that human societies have also a lot of social factors involved in the decision making, how they will manage the landscapes. So human societies are usually not just disturbances in the ecological or environmental relationships, but there are a lot of very irrational decisions behind what people did in the prehistory. So we know that paleoecology is going already on the way to big models of vegetation, but I would say that archaeology also made a huge step forward. So we are now creating large data sets which can provide other disciplines, but also us, with a long-term and large-scale perspectives. So we have now some global databases of C14 dates. We have also some national databases of sites, etc., etc. There's also a big advancement in computations in archaeology, and that is something very different from what was possible, for example, 30 years ago. There is a lot of discussion, a lot of research in demographic archaeology, and also land use quantifications, because we kind of would like to know how the archaeological evidence can be translated into what people actually did in the past. Archaeology is also doing quite a lot of advancement in geoarchaeology. So on a specific sites, we can infer much more detailed information of what was going on. There is a lot energy put into environmental archaeology, and of course we cannot forget also about the Anthropocene and the whole movement into environmental humanities. And if we have a look on the global context of all these studies, we can see on this chart that the amount of papers dealing with those topics, with topics related to human-environment interactions, actually went up very significantly after the first IPCC conference at the end of the 80s in Geneva. And this is the number of those papers in major archaeological journals in the world. So therefore, we tried with my previous team do something about it. So we were based in Czech Republic, and we got funding for this project, or trying to reconstruct or do research into land use, social transformations, and woodland in Central European prehistory. And we wanted to apply modeling approaches on that topic. So Czech Republic, you know all where it is, and it's in Central Europe. The big advantage of this country and for this particular research is that we have all the databases there already, so we can just play with the data. So we have a pollen database, we have archaeological map, or there is an archaeological map of Czech Republic there with hundreds of thousands of records of archaeological sites from the whole Holocene basically. There is, during this project, we also created archaeological C14 database of covering the whole country. And because we were also interested in the current vegetation, we could also use the Pladias database of Czech flora and vegetation, which has more than 6 million of records from, let's say, last 150 years of botanical research in that country. Here is some coverage of some of those data sets, and now the results. So the first part is about the population dynamics during the prehistory in Czech Republic. In this first paper, which was published last year, we asked about, is there evidence of regionally specific demographic trajectories, or was there some uniformly applicable demographic trajectory in the prehistory, and what social or environmental processes might account for them? So why people lived in different regions and why they didn't in other? What was the spatial extent of human settlement during the prehistory, and was it stable or more dynamic? And are the demographic patterns reflected somehow in the vegetation during the past? So here are some of the results. So because this paper was going into demographic archaeology, we were first trying to do some analysis on the C14 dates. So we did summed probability distribution, which is the most common technique how to infer some of those population developments, and we compared it with something similar but based on archaeological sites. So here are around 1,500 C14 dates. Here are, I think, if I remember it right, 65,000 archaeological sites. So you see that the scale is already very different, and you can see that what they have in common is the very low, probably very low population during the Mesolithic, and with the Neolithic population rise. Right here. That is quite common. Then there is this decline in population based on sites, based also on the C14. Here is some weird thing going on in the middle of the Copper Age, and then there is a rise in the early Bronze Age, and the C14 is then going down again, so people were dying out probably after the Middle Bronze Age, based on the C14 data. But the sites are telling us completely different picture. So here in these squares, or in these rectangles, you can see the same period, so between 1,500 and let's say 1. BC. And you can see that if we would use just the C14 based curves, or the summed probability distribution, we would say that people were there was just a little bit more people than during the Mesolithic. But if we use the sites, we see that during the late and final Bronze Age and in the Iron Age, the amount of sites is really high, and therefore we can say that some of the proxies, and especially the C14 date for that country, the summed probability distribution is not very reliable for demographic reconstructions. Yes, so therefore we continued only with the sites. What we did, so we were interested whether even such a small country or middle-sized country has regions with different demographic histories. So we did some clustering, and we said to our model, please provide us with spatially constrained clusters which have similar demographic trajectory, and then do whatever you want. Create us 10 clusters which are not spatially constrained. So these clusters of these squares can be wherever within the country. So we can see here that there are different regions in the different colors. And what we see here, that this green one is not very settled. There is not that much archaeological evidence. And then we have two regions which have been settled more or less continuously. This is this orange one and this green one, which are lowland regions, a lot of archaeology all the time, basically. And then we have some other peripheral regions, for example, this red one, where you don't see that much evidence in the Neolithic, but with the early Bronze Age, it is just going up. Here we were not interested in the spatial constraining, and we allowed the model to give us more complicated picture of the demography, so that the squares within our grid did not need to be connected spatially. And with this procedure, you see that the picture can be a little bit more complicated. So that, for example, this red region, where here it is indicated that the settlement started mostly in the early Bronze Age. So if you have a look on this fragmented part, you can see that the green part was very similar to here, but from early Bronze Age it was settled continuously. If you have a look on the other parts of this cluster of settlements, the blue one and the red one, we can see that there are some breaks in the blue quadrants, and the red ones, even the periphery of this one was settled even later, and only for the Iron Age, and then it was more or less abandoned again. So what does it tell us? We can continue with those clustering procedures again, and we created this categorization of the whole country, where we have continuous settlement areas. We have some kind of stable periphery, more or less pulsing periphery, where people were coming in and leaving again the areas. And then we have some areas with very minimum settlement activity, and people were not there very often, and then areas with zero evidence of the settlement. The question is why it was really happening like that. So the lowland areas in here, this is the orange part here and here. That is quite obvious. So people, the first farmers settled there because of the conditions for agriculture and animal herding. But the question is, for example, again with this southern Bohemian region, which has only very sparse evidence of the Neolithic communities, but there was a lot of hunters and hunting and gathering communities living all the way to the Copper Age. So this area was not unpopulated. There were people with different economic strategies. And why this southern Bohemian region was settled in early Bronze Age? Well, this is very much connected to more global developments, because in that period, in early Bronze Age, the copper exchange networks actually shifted from the Carpathians to Eastern Alps. And if you're familiar more with the geography, here is Upper Austria and actually Eastern Alps. So this region was very much on a crucial trade route between central Bohemia and Eastern Alps. So that's why people moved in there and started to settle that much more densely. Does this different demographic development had different impact on the vegetation? We would say that yes. So again, to make it more simple and more easy for the analysis, we went back to our spatially continuous regions, and we picked up some pollen profiles from those regions, and we compared them, as you can see here. And what we can see. So we see that that in the Copper Age, let's say after or between 4000 and 3000 BC, there is in most of these regions there is a population decline. This is nothing unique for Czech Republic, for that region, but you can see that in Ireland, you can see that on the Tells in Romania or Bulgaria, you can see that basically everywhere in Europe, just a little bit shifted one couple of hundred years here and there. We see the same. So the question is, what was the impact on the vegetation? So at the beginning of the Neolithic, there are farmers coming in, starting to do some agriculture and animal herding. And after, let's say, 1,000 years, there were a lot of these farming communities were not there. However, the legacies of their land use were still visible in that landscape, and the vegetation was in a different stages of succession. And exactly that is visible in the pollen records. If you have a look on the variance of the pollen, and this is signifying that exactly in that period between 4000 and 3000, the vegetation was much more variable across this area than before during the Neolithic or a couple of thousands years after, because there were still some of the farmers living in the landscapes. A lot of the landscape was abandoned, so there were successions, and there were also landscapes which were not touched with many people. In the vegetation, we see that the central areas, the lowlands, were very much there was a lot of impact on the vegetation from the farmers, because they needed open landscape. There was a lot of herding, etc., etc. However, although we have evidence of prehistoric farmers in southern Bohemia or somewhere else, and especially from the early Bronze Age, the settlement was intensive also there. Their impact on the vegetation was not similar as in those core areas, and they were involved much more in the woodland management than the lowland communities, which were creating much more open landscapes compared to those peripheral regions. So I'd stress that the Neolithic farmers within that area, they differed in their land use, and also the prehistoric farmers differed during the Holocene in their land use, and it was not uniform. Our second part of our project was kind of revising the pollen anthropogenic indicators. Why? Why is that important? The thing is that the concept of pollen anthropogenic indicators was, I think, invented in the 70s or beginning of 80s, when some pollen specialists, they just looked around the human or anthropogenic environments, and they have seen what kind of vegetation grows there, and from that they inferred what kind of pollen is indicating in the pollen profiles the human activities. There are only a couple of studies which are actually analyzing that together with archaeological data, but we are still very much questioning to what is the spatial scale of that relationship, and that's why we did this paper. So we asked, what is the spatial scale for comparability of the archaeological and pollen data, and can archaeological proxies explain the variability of the vegetation? And our last question is, what is the relationship of anthropogenic pollen indicators to archaeological record? Again, we did some basic side-by-side correlations, and you see that by this very simple, I would say, quantitative quantifications or statistics, we see that there is not a lot of correlations between the pollen anthropogenic indicators and the archaeological data. Only very few. However, there are some interesting correlations between the tree pollen and the settlement dynamics. So we introduced other modeling techniques, and then the results were a little bit better. So cerealia, like the cereals, obviously very much pollen anthropogenic indicators. They cannot grow without people in prehistory, so they correlate with the settlement evidence around the pollen profiles quite well. There are also some other species, but there are some of them, they just do not correlate at all. So although they are used quite often in the pollen studies, when you really statistically analyze them, they have no relationship to archaeologically detected human activities at all. What is interesting is that also some trees are indicating very nicely or have some relationship to archaeological evidence. So very good is very good correlation between human activities and pollen, as in the case of oaks. That is quite well known, but in our case, it is nicely correlated. However, because people were deforesting in most cases the landscape, so the total sum of the tree pollen has a negative relationship to the archaeological evidence. What was the most interesting for me as archaeologist collaborating with palaeoecologists was the spatial scale of this comparison. Because when I was working at the Institute of Botany, so there were friends, palaeoecologists, coming to me and saying, "Yeah, I have this pollen profile. Would you mind finding me some archaeological data, and then we can compare that?" So my first question was, what do you think is the spatial extent of the pollen you have in your profile around your pollen profile? And they usually say, probably 3 to 5 kilometers. And even in a very densely populated landscape during the prehistory, I can find in such a buffer around the pollen profile maybe 15 archaeological sites covering the whole Holocene. And from that, there's not that much fun to do with in archaeology. So we analyzed that actually. So we analyzed which buffer is ideal for studying these interactions. And what is very interesting is that you can go much further. If you are, for example, interested in the vegetation from the perspective of herbs, you can go. The best results you will get at 15 or 20 kilometers around your pollen profile. And if you are interested in woodland, you can go even further to 30 or 40 kilometers. So this is the buffer from which you can consider the archaeological evidence, which the archaeologically evidenced communities which were impacting the trees, producing the pollen, then ending up in that profile. So this is I would say one of the first studies of that, and this is very much in contrast from the recent studies which were indicating 4 kilometers for tree pollen and only hundreds of meters for the herbs. And our last paper was somehow connecting the recent vegetation and the past settlement. Because, as you know, the prehistoric farmers were drivers of invasions of plants in the past. So we focused in that paper on archaeophytes, which are plants which were introduced into the native environments prior, let's say 1500 common era. We have some lists of these plants which are coming from the Near East or which are coming from the Mediterranean or Balkans, which were kind of hopping into the agriculture, spreading into Central Europe. And the question is whether these plant taxa are still kind of reflecting the prehistoric settlement patterns of the past. So the data sets which we used were again archaeology, so again 70,000 archaeological sites, let's say covering the whole country. We have some forest cover, the recent forest cover, we have some recent elevation, and also we used the Pladias database, the 6 millions of records, which have also the archaeophytes. Again, we did some fancy modeling procedures. The details you can find in those papers. And what do we find out? We found out that the more native species you find somewhere, you find also the more archaeophytes. So the conclusion from that is that those introduced species did not compete that much with the native plants, and actually they increased the regional biodiversity under moderate human impact. This is not very much answering our questions, because we were interested whether the archaeology has still impact on the recent vegetation. So we did some more analysis here, and here is one of the results where you can see what is the explanation of the variance, and you can see that the environment, like which is the deforestation, the current this is the current land use, the elevation, and archaeology are kind of overlapping, which is quite understandable because people in the prehistory were mostly in the lowlands. And most of the archaeology we know also from deforested landscapes. However, there is part of that variance explained solely by archaeology. So there is some part of the variance of the spatial distribution of those species explained only by archaeology. We also compared our results with a minimum residence time, because we have also archaeobotanical databases for Czech Republic, and from those databases we can have evidence of those species coming directly from the archaeological sites, and so there is a positive relationship, but between the spread of those species, but it is not significant. So our conclusion was that there is a indirect relationship between the current spatial spread of these archaeophytes and the extent of the prehistoric agricultural settlement. The question is now, why do we need all this? Why do we need to do research, interdisciplinary research, trying to analyze what are the origins of the current vegetation, or how people, or what was the impact of the prehistoric communities on the past woodland? And I would say that we can learn from the past, and we can adjust our current land use and landscape management to have just better lives, and to maybe survive the environmental change. And that's why archaeology in this way, in this interdisciplinary way, can be very important for the current societies. And to conclude, so if we want to speak about the role of humans and the past ecosystems, we need to work with data on the past humans. So only the palaeoecology cannot tell us actually a more holistic or big picture about these interactions. Archaeology is nowadays ready to provide this quantified data needed and qualitative knowledge on the past societies and their activities in the landscapes. And only the truly interdisciplinary approaches can push the research on the human-environment interactions forward and inform also the current policymakers on what to do for our sustainable future.